the results is saved in your browser somehow, but I'll try to see how to catch it in the next time you actually view the browser. All right. Today we'll be learning about APIs, APIs fundamentals. Basically, again, I'll be teaching you the fundamental. Intentionally, I'll only be discussing about REST API for GraphQL and gRPC. I will not go in depth, but I left a bit of um, documentation here so that in case you want to learn more. Most APIs that we have today are REST APIs. They are not GraphQL or gRPCs. GraphQL is used mostly with chat systems, right? Where structure is not really a thing. Or where we require. I feel like I'm explaining this too early, but let me just explain so that when we get there, it will make sense. Where we require more of speed than structure, right? So we use GraphQL. Maybe, for example, in the case of WhatsApp, we probably find GraphQL more palatable. In the case of email, right, we speed is more prioritized over structure, and I'll explain what the structure part means as well. All right. So, but first, what is API? So, in the grand scheme of things, when you hear API ideally in most cases is considered as an interface. Just take it, see it as, in fact, everything in software is an interface, but API in specific is an interface between mostly in most times two or three parties. So let's think about it this way, that to be able to reach, say for example, to be able to reach your, I don't want to use the most common analogy. I'll still use it, but I want to use something different that will at least help you guys, because every time I use that common analogy, people get confused. But yeah, to be able to reach the HOD, most of us here have been in school or we are currently in school, right? So to be able to reach your head of department, you oftentimes have to meet the secretary, right? So the person between the HOD and you is the secretary. So that means that if you want to tell the HOD anything, you tell the secretary. The secretary goes to meet the HOD. And in most cases, the HOD says, "Oh, we don't need to see, just give him this document." And then the secretary collects the document and give it to you, right? So the secretary in that particular analogy, so to say, is like your API. So API, anytime you hear the word API, it's basically an interface that stands between two or three systems that allows them to talk together in a way, right? So it's like a protocol. We'll still talk about protocol. It's like that thing that understands the language of, in the case of in the example I give right now, it understands the language of the HOD and then understand the language of you as a student. I know we don't see secretaries as like huge, but they are doing a lot of complex work. Understands the time to actually go and meet the HOD, or to understand the time to tell you, hey, come back later, right? Understand the time to tell you, maybe you come and you say, I don't know, and the HOD doesn't like when people are like that, and that's why usually there's a secretary. So the secretary absorb the whole pressure that you're bringing, and then takes down all your query. Right, student come and say, "No, we have to, yeah, calm down, calm down, calm down. Tell me what you want, right? In a simple way." And then when you explain to the secretary will say, "Okay, that's what you want. Let's assume you speak with the secretary for like 1 hour. Then the secretary will now go to the HOD and just say a single word to get what you need back and bring it back." And why was the secretary able to do this? Because the secretary understands what the HOD requires and then what you require, and then can convert it in a way that is not wasting both of your times, right? So usually the secretary in this analogy is an API. I'll use the general example of a restaurant, right? If you go to an average product manager, especially those that are trained in Nigeria, will give you this example when they are explaining API. But it doesn't always work that way. But again, I'll give you an example. So you go to a restaurant, you as the user, you have server. Your server is considered the API in this context, or should I say, I don't know what they call it. They call them servers now, right? In bougie restaurants, they call them one romantic name, right? I don't know. Sha, this person comes to you and say, "Hi, how are you doing? How can we serve you today?" And then you tell them, I want, hmm, what's your egg sauce like? Say, it's actually very good, but I would suggest that you pair it with bread, right? And you ask the person, oh, I want water, and the person says, okay, do you want cold one or hot one? And say, okay, I want hot one. Okay, how do you want the hot to be, right? That server converse with you to understand what your need is. However, when the server gets to the kitchen, in most cases, especially in fancy restaurants, where I don't know if some of us have been to it, I've only been to one, I've only been to a fancy restaurant once in my life, where there's actually no really menu, there's no menu as such. Yes, there are menu, but I mean, you get to curate your experience. And then when this guy gets to the kitchen, right? He doesn't go there and say, they want jollof rice and chicken. No. There's a way that he's able to communicate that thing that you said. Oh, I want it to be I want it to be cold. Let me use an example of, I don't want it to be cold, I don't want it to be hot, right? So when he gets to this thing, he says, for example, room temperature, right? To you, you don't know that there's something called room temperature. I mean, hypothetically. But to him, he understands that what you need is room temperature. So he goes to the kitchen, gets exactly what you need, and when he comes back, it is well presented. But in most cases, he's not communicating exactly what you gave to that person on the back end or in the back office. Let's call it back office. In the I don't want to use technical term, in the kitchen, right? And then when he communicates to the kitchen, usually at the kitchen, there's one person in the kitchen that is actually taking orders from that person. That person in the kitchen as well would have to speak to those that are actually going to cook whatever it is they're cooking, right? Prep it. In some cases, there are some meal that require the chef himself to come and serve it, right? In such cases, it tells the chef you need to prep this, blah 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 blah. But the most important part is that there's somebody that have taken the input or requirement, so to say, from system A or from person A, and I've been able to bring this requirement in a way that person B will understand, even though both of them are in different level of reasoning. This person is ideally who we'll call an API. In the case of software, right? I'll use this my website as an example, right? This is the front end. This is what you guys can see. Is when you click here, you click here. This is what you all can see. However, this recording that we have here, you are seeing it because it is seated somewhere, right? It was saved in a DB. So which means there's another system that keeps all this information that you guys are seeing here, even though you are seeing it on the UI. So the UI is a system, and what does that system do? It collects information from another system and then present it in a way that you can see it. Now, in other words, there's another system. In this case, where is it? Called a Google Sheet. Let me just go to the where is it? Video. Where's my video? Where are you? Where are you? Where are you? I think admin. Why am I not seeing them? Config, yes. Right? This is what my database looks like. Again, sorry, that is messy. I'm using the Google Sheet as my database because I don't have plenty money to be spending on database. All right, so this is what my database looks like. Another system. So again, this is the major system. This system is trying to collect data from that database so that I can show it to the users. So now this system does not have data of its own. So if I come here now and delete all of this information, for example, delete. Right? As you can see, there's no video anymore. So the work of this interface is just to show you or showcase sort of collect the data in the backend and then clean up the data such that you can see it in a presentable manner. That's what this system does. The other system, however, keeps the data, right? Keeps the data in a format that might be clean or might not be clean, right? Now, for this guy to be able to collect, I mean, at least we can see that what is on the back end is just a link. So how did this link become a video that can be played, right? This particular API is something you are not seeing here that is handling that process where the front end is able to take that back end data that makes no sense right now, able to take it in and convert it into what the other system can understand. I think you can understand why I use the you and your HOD analogy right now, right? This guy wants to collect the data. The data does not make sense because now I want to play. But if this guy comes to the database itself and come and take this video, it probably will not be able to make sense of it. So what we do is we create an API in the middle that takes the request from this guy, however vague it is, or whichever we call it contract anyway. This guy defines that, okay, this is how I will communicate to you. I will tell you, give me video, for example. And then the backend says, okay, it will tell you, give me video, but there's a lot of videos. So how do we ensure that the communication is better? Okay, maybe you can tell me, give me video for week 1, day 1, right? And then this one comes out and says, give me video for week 1, day 1. And then the backend comes and goes to the database. The API goes into the database and looks for video for day 1, week 1, and only shows that on day 1, week 1, instead of showing it everywhere or messing it up here. So ideally, the API usually is that part of the system that you are not necessarily seeing that does the communication between both systems, that helps two systems to communicate, ideally. Now, does this mean API is only applicable only when there's a front end and a back end? Not necessarily, right? APIs can also communicate between systems and systems. That means a backend system and another backend system. I'll give an example. An example will be Paystack. At least most of us know how Paystack works. Paystack is a company on its own. Chowdeck, at least I'm expecting that some of us have ordered from Chowdeck before. Chowdeck is another company. Chowdeck uses Chowdeck basically allows you, for those of us that have not used Chowdeck before, they allow you to actually order food anywhere you are and they deliver it to you. That's what they do. Paystack, on the other end, they provide a service that allows businesses to actually collect money from any customer that wants to buy from them. So like a payment gateway. So now, Chowdeck does not have license to actually collect payment from customers. However, Paystack has the license. So Chowdeck comes to Paystack and say, hey, I want to use your license so that I don't have to pay the license, because the license is so much to even get CBN to approve the license. I have to have 100 million naira in one account sitting there not doing anything and have another 200 million naira in another account just sitting there. I don't have that kind of money. So Paystack, please, you have the money. You've gotten the license. Can I use your license to collect money from my customers? Then Paystack says, okay, no problem, no problem. How do you want to collect the? You have that conversation, right? And after having that conversation, Paystack gives Chowdeck an interface that Chowdeck can call every time they want to make payment. So Chowdeck calls that interface, in this case, an API, calls that interface and say, hey, Paystack, I want this customer, for example, Nkechi, wants to buy 2 pairs of perfume, 3 pairs of blah blah blah, or the food, or let's say item 7 mixed with chicken, and his money or our money is 10,000 naira, and then that interface converts it into a language that that Paystack understand. You know, Paystack is a payment system, and then goes to Paystack and say, hey, Alpha, this person wants to make payments. Who is the person? Is it Chowdeck? Obviously, Paystack has a lot of other customers, not just Chowdeck. He needs to be able to understand that it's Chowdeck that is calling me. So, all those abstraction, all those understanding, the interface understands it and then goes to Paystack. Then, because the interface already got all the information it needs, it's able to present it to Paystack, and Paystack is able to take the action. Afterwards, Paystack replies back and say, "Hey, Chowdeck, I'm doing well." So, which brings me to the part where I want to talk about the fact that APIs themselves does not just undo collecting, they also undo answering you back. So when you have an API, that API is that system in between that can basically help you communicate with another system, ideally. So me and Dogo can communicate together with somebody in between us to help us work effectively. For example, another example I like to give is that, for example, let's assume Dogo is an
I'm sorry
amazing
to
person.
interrupt you. Hello. Olushola, are you
Yes.
sharing your screen, displaying the
No, I'm
API?
not. I'm not sharing my screen actually. I'm trying to explain before sharing
Oh,
screen.
okay.
Yeah,
Oh,
yeah, yeah.
okay.
I've not got into the screen sharing part. All right. Um. So let's say Dogo is an amazing translator, right? Dogo has lived in Sokoto for a very long time, so he understands Hausa, and then he has also lived in Ilorin, for example, and he understands Yoruba, so he can speak both language. Now, Nkechi only understands Hausa. I, on the other hand, only understands Yoruba. However, um, we need to communicate to each other. So Dogo comes and say, "Hey, I can help you guys." In this case, Dogo is an API. I talk to Dogo and then Dogo translates to Nkechi. Nkechi talks to Dogo and then Dogo translates to me, right? This is basically what an API is. So because of that, Dogo has to be secured at all costs. Again, I'm explaining all that so that when we get to the material, it makes sense to you. Because of that, Dogo has to be secure at all costs. Because I don't want somebody else who is not Nkechi to actually talk to Dogo and Dogo come and tell me. And at the end of the day, it's wrong information, right? So Nkechi and I have to agree on a way that I will know that truly, truly this message came from Nkechi and not from any other person. Or Dogo is just acting up, right? For example, Nkechi might say to Dogo that, "Hey, let's use English. I'm looking for a language that is neutral to both of us, or let's use English and Pidgin. I'm not very good at Pidgin at all, but let's say English and Pidgin. Let's assume I understand English and Nkechi understand Pidgin, and Togo is our translator, right? And Nkechi comes and says to Dogo, um, um, say for example, tell him say Yawa don gas, right? Tell Shola say Yawa don gas. Let's assume that's what Nkechi told Togo, and then Togo during translations decided that, oh, Yawa don gas means that, oh, Yawa has actually got into gas. And then he comes to me and say, "Hey, Shola, you know, Nkechi says that Yawa has gone to gas." It means that whatever Nkechi expects me to do at that point has already been truncated. So, which is why companies employ people intentionally to write these APIs. And those are the people we call backend engineers. Your backend engineers, their main job is actually to write APIs that can help two systems communicate. And those systems is your visual system, which could be your website, your mobile app, chatbot, any interface that the user use, and then your backend, which is basically your infrastructure, which could be your database, it could be your AWS, it could be your Lambda function, it could be, well, Lambda function is also an API, but then it could be your S3 bucket, which saves your PDF and documents. Basically, it could be anything. Basically, your infrastructure versus what the customer actually interacts with. So when you hear backend engineers, what those guys do is that they build APIs. Basically, they build that interface that allows the user to interact with the backend, which could be, like I said, your infrastructure, your database, etc., etc. All right. So as I've explained, an API basically is that contract that lets two software systems talk to each other. It could be backend to backend. That means it could be the example I gave right now, backend to backend, which means that Paystack backend to Chowdeck backend, or it could be front end to backend. That means my front end. This is not a different system now. My own front end itself to my backend, right? That can be the case. It could be anything. In this example, I say when your banking app shows your balance, it is calling your bank's API. That means that interface that the bank has built is calling that interface to actually go to the backend to fetch your balance, right? From in the backend now, the part of the backend that keeps your balance is what we call the database. So that API is built to go to the database and fetch your balance for you so that you can see it on your front end, basically. So your backend engineers write the APIs, and then your front end engineers work on the front end, basically. All right. So when Paystack processes a payment on a merchant's website, the website is calling the Paystack's API. I think that makes sense now, right? I hope it does. So I gave the general example that everybody gives, right? An API is like a waiter in your restaurant. You, the client, you don't go into the kitchen. The server is the one that goes in the kitchen before for you. So you tell the server or the waiter who is the API, and then he goes into the kitchen to get the food and bring for you, ideally. All right. So now, because of this API, I said that there has to be a way to be sure that Dogo is not miscommunicating what Nkechi has communicated. The way that in software we ensure that this is done is what we call standards or protocols, right? Or ideally standards. We call it standards. These are like rule system. Sorry, guys. Give me a minute, guys. Sorry. All right. Sorry for that. So the way we ensure that like I used the example the other time, that Dogo doesn't come and explain what Nkechi actually explained initially is what we call standard. So these standards are the same everywhere. So if you go to company A or company B, wherever place you work, get will always be get, post will always be post, put will always be put. It doesn't change. The only thing that happens is more um more types or standards really are added to it, right? So we have different ones, like not just one. There are just so many, but the one that is very very popular is your REST APIs. And okay, so let me, before I go to standard, let me talk about protocols, right? Some of us have seen the most common one is the one for web, which is your HTTP. So you have, I don't want to go into network architecture, but it makes more sense later. So you know that anytime you want to enter your website, you have to type HTTPS, right? The reason why you are doing that is because this HTTP belongs to a group of protocol that the word that is your entrance, the entrance to your house, right? For somebody's house, it might be key that you use to enter. For another one, it could be key cards. For others, it can be buttons, right? For others, it could be voice. Open the door and the door opens, right? So these are, I consider these guys are protocols to different systems, right? So for the website as we know it, the HTTP most common one that we use. We also have file transfer protocol, which allows you to use applications like Zenda to send files from one Android device to another Android device. I can't hear you from here. Can you guys hear me? Mic check. Oh, I can hear you now. Lovely. Right. So you have the HTTP protocol, which allows you to actually transfer files on the web interface. Then you have file transfer protocol, which allows you to transfer files. Basically, for example, your Zenda. Most of us know Zenda. At least before we started using iPhone, we used we used Android at some point, right? We use Zenda, right? Those are file transfer protocols. Um, we have quite a number of protocols ideally, but for the sake of this course, since most of the products you will be building will be built for web, we'll probably talk about HTTP, which is the standard for web protocol. Now, this web protocol now have standards. Like think of it like style, right? Say that how do we, or like a different way that most common is REST API. So when you hear people talk about APIs, you always hear them talk about post, push, put, delete, patch, right? But there are other styles as well, which we can call standards. We have GraphQL, we have GPRL. Aside from REST, we have about 7 or 8 that I know of. I'm sure there are many out there, but the one that most companies use that is standard is REST API. And the reason why they use it is because it is more structured. It has a more structured approach. It is predictable, right? And if something is predictable, it makes a lot of sense to use them. Another one that is common is GraphQL. It's not as predictable, so to say, like the REST APIs. They're not as predictable. Not like they're not as predictable, but they are more flexible, right? And faster, way faster than REST API, because you don't have to structure a request somehow. You don't have to, there is no, how do I explain it? You can, it's complex, but just know that for you as a product manager, GraphQL is faster than the rest. And that's why most times it is used in systems like chatbots, WhatsApp. WhatsApp has a GraphQL. Um, Messaging, every time that you require to get randomized data. For example, if you're on Instagram, I am seeing a different set of number. This person is seeing a different set of number. Everybody's just seeing set of information. You can be on Instagram now, somebody else can be on you can be on Instagram story, somebody else can be on post, somebody might be trying to upload. Like, it's just different dynamic actions happening at the same time. And when those actions happen, I need to be able to query the data as fast as possible. And query means that I need to be able to get the data from the backend as soon as possible. Usually, in most cases, GraphQL is applicable. But if what you're building is something that requires structure, security as well, more that would probably communicate with multiple systems, then REST API would be something you should always think about, because REST in its glory is used by a lot of companies already. So it's like a standard for HTTP protocols, right? All right. So now to the REST APIs. There are 5 different methods. I'll sit with you better on methods tomorrow. In fact, tomorrow we'll talk mostly about methods and codes and everything. Today, I wanted to take time to explain what APIs itself are. I don't want to just go into us doing API testing and then you're like, man, what's going on? So that's why I'm taking time to explain. So with REST, we have 3 major protocol. I'll still explain them tomorrow. The first one is GET. So which means that the front end or system 1 can ask system 2 and say, get me the phone number of Joseph. Get me the home address of Adiola. That's GET. GET is used to basically collect data. Usually it's read only. You are not updating anything on the third party system, right? Or on the other systems where you are getting the data from. Now, we also have post. Post in most cases is used when you want to update something. For example, Remember I said get is like get me the phone number of Adiola. But let's assume you want to tell the second system that, hey, this is the phone number of Adiola. Save the address of Adiola, right? That's a post request. Not necessarily, because this will give me a bit of complexity, right? It give me a bit of complexity. But post is like when you are taking a whole number and say, okay, let's assume you have. I think I'll give an example of where post is applicable and where put is applicable, because both of them, they are very similar. Let's assume we have a student record, like a record of students in a school, right? You have, let's assume all of you are students, right? You know the way Jennifer joined, right? So we have Jennifer joining afresh. I had a table of everybody's information, your phone number, your email, your everything, and all that. So I had a table of all those information. Now, Jennifer joined. I need to add Jennifer's information into it. What I will do is a post request, because Jennifer is still very new in the data. However, if I need to, for example, say Jennifer decides that, hey, Mr. Michael, or very good example, Nkechi says, hey, Mr. Michael, I used my work email to join. Please, can you please remove it from the database, right? Replace it with this particular email. What I'll do is put, because put handles more complex updates. And what does complex update means? In the case of, all right, in the case of post, you are just sending the data, like you are just updating. It's like you're adding something new into the cup, right? Think of a cup that you're adding balls or dates or I don't know, anything. Like you're adding things one by one, right? For post, you are just adding it. Now for put, because Jennifer already exists in the data already, or sorry, I was using Nkechi as example. Because Nkechi already exists in the system and I want to update Nkechi, I have to first go and check that is Nkechi truly in the system. Then I'll bring Nkechi out, and then okay, I want to add something to Nkechi. Then I'll add it to Nkechi before taking it back. You see how that is complex, ma? If Nkechi was not in the system at all, and I need to just put Nkechi in the bowl, in the cup. Let's assume we are putting everybody in the cup, just to make it understandable. All right? Aha, very good example, right? So I have these 3 rings in front of me, right? Let's assume I want to put this ring into this cup. That is post. Like it's a simple ring. I want to put another one post, another one post, right? So we have 3 rings. However, what if I'm saying that take this particular ring, right? Put it inside water, and then put it back there. That means I want one of the ring to actually be moist or to be wet. So I have to first confirm if I give this request to the API has to first confirm if the ring is there. And if the ring is there, it now takes the action that I want it to take. After taking it, it now updates it with that action. Now, that is why in real sense, put is for more complex updating of data. Sorry. All right. So ideally, the difference between post and put, both of them are adding to the database. However, put is used when you have more complex action to take. For example, I need to add information about, it's like think of put as update, but in a more complex way, right? I want to add information. For example, I can say, okay, I can perform an action like filter by every student that are less than, for example, 30-year-old, and update them as Agba students, for example. Update their status as Agba students. Any student that is less than 30-year-old, update them as Omode students, for example, right? Like small students and then older students. You see, that that request that I'm sending to the database would first require it to first do a get and then do a post. So you are doing it in a single request, which is put. That's the complexity of put, basically. That's one advantage that put has. When I explain this, it's always a bit complex, but I hope you get it. Right? The main one that is very popular is the get and post, but put usually we use it usually when you need to update or replace something regarding an existing user. Patch, on the other hand, patch is when you are actually updating more than a single field. So think of it this way. How to explain it? So usually, where how I use patch or how I had seen patch being used when you are doing either multiple 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 updates of a single, or I'll give an example. Example is better. Say I have looked at all of you and I realized that Joseph, Adiola, Nkechi, Jogo, and Jennifer passed their assessments. And instead of updating them one after the other, I want to update all of them. Usually that's the case for patch. But how companies use it, which I believe is entirely up to everybody. Some companies use it to actually update singular items. So think of a column. They used to update just a column from a row. But in most cases, it's more powerful than that. Patch is used to do multiple, like you're doing multiple updates at the same time to make your work really faster. One single request does the work for you. And then you have delete. I don't have to explain delete, right? So this is the top for the REST API. So this makes it easy. So that when, remember the first example I gave, when Nkechi says, hey, Yawa don gas to Musbao, Musbao can explain to me in a simple term within these three without necessarily having to mix word. That way, the action is defined regardless, right? So you say get or post or put. Everybody knows get is get it, post is post it. So there's no, you cannot come and say, oh, getting as a method. I'd say I don't recognize the method, right? All the methods are predefined, and that's one of the things that makes REST API one of the best standards that we have currently. I mean, before AI. Now that AI is here, now we have other. I already explained. I already gave you guys a hint into the AI standard that is called A2A, which allows agents to communicate to another agent. I also give an example of, I think that was like one of the first few classes we had. I also explained, what's the name of this server? I still worked on one today. Uh, Somebody remind me now. One of the ones that we spoke that I said allows agents to
Is it
communicate to
MCP?
tools. AMCP, thank you. So that's another standard that allows agents to communicate, or LLMs ideally, to communicate to tools, right? Tools can be your CRM, your Shopify, or allows them to communicate to tools, right? So before AI became a thing and these guys came, REST was like the standard, like the senior standard of the standard. And I think it's still very much valid today as well, even for systems that build AI, because at the end of the day, the tools will still have to communicate under the guise of a standard, right? So think of it that way. Tomorrow I will try as much as possible to explain more on methods and codes, and then how to read documentations and all of that. We'll discuss that tomorrow. For GraphQL, I will not go in depth into it, but ideally, let me switch to dark mode. Yes. For GraphQL, ideally, what we have is, as you can see in GraphQL, here you have query, user ID, name, email, post. You see complex actions at the same time, yet is very fast, right? Usually that's what we use GraphQL for. For gRPC, usually this is used in the case of we all oftentimes only use it for authentication, authorization, and all of that. But again, I personally have not seen it in action with building softwares, but mostly most of the companies I've worked with either use REST APIs or GraphQL, right? I've not seen this a lot, but it will most likely be more. It will be more. What's the word? More applicable with systems maybe like SMS systems that are very straightforward in, like, it's either true or false, go or come, or things like that. Simpler, right? All right. So I want to just talk about authentication. Authentication is like, so now this API, right? Think that API, Paystack now is exposing their API, which means that now that you understand what Post gets, which means that if Paystack gives you their API, you can basically update things on their end, which means you can, if you have I don't know if you've seen this joke in the internet before, that developers are very, very rich in their local environment. I can update my balance to be 1 billion, right? So because of that, because as a developer, API already gave me, Paystack already gave me access to their API, which means now I can update balances, right? I can transfer money if I want. Paystack needs to be able to add a level of security. And this level of security is what we call authentication, right? Authentication is like, it allows a Paystack to know that this is the person that is trying to make this post request or this get request. And then when they know, it also gives them the ability to know what kind of access, or in most cases, it might not be encoded with the authentication. It might be such that after the authentication, after they know that it is you, they now make another request, right, to know what you have access to and what you don't have access to. I'll still show you examples of API requests. We might play around maybe Paystack or any other APIs tomorrow, just so that you guys know how it works, right? But here, tomorrow we'll do more practical. So that authentication layer is what helps developers not steal money anyhow. So when they have this authentication, I can say, okay, this is test authentication, so you can do anything you want, right? But this is production authentication. You cannot do anything you want to. To be able to do this, you need approval from your CEO, for example, right? So authentication ideally gives that balance. Now we have 4 different types of authentications, and I'll tell you where they are applicable. Right, we have the API key, which is the most common one when it comes to public APIs. Right, companies give you API keys, and then you're able to call those API with those API keys, right? And then you have OAuth. OAuth is always used when you have native integration. For example, when you want to sign up for Booch, right? .new, so you have to log out. Okay. So when I want to sign in on both, right, it shows me signing with Google, signing with GitHub, signing with email and password, signing with SSO. So what these two means is that even though I want to sign into both, they want me to actually sign in using another app that I have, right? That would have been very complex, right? Without OAuth integration. So what OAuth does is it allows me to sign in to Google and this particular system simultaneously. So once I sign in here, I'm able to sign into my Google, and the moment I am authenticated with my Google, they can use that token that Google has given me on the back end to actually authenticate that this is truly who I say I am, right? So that is what, in its sense, when you are dealing with integration between two systems, OAuth is usually applicable, almost always applicable when you're integrating between two systems. There's also the JWT token. JWT token is applicable when your front end is communicating to your back end. If I show you an example, let's go to Paystack, right? I always use Paystack as an example. I hope they. All right, right. As you can see, they generated a token. This token has an expiring, so to say. But yeah, it generates this token so that every other page I want to click on per time, they are able to use this token to verify that truly it is me that logged in initially. So usually tokens are applicable a lot of time when you're trying to log into systems, especially from your front end to your back end internally, right? We use tokens. We have different type of token, by the way. We have the JWT token, we have the S2S token, we have different type of tokens, ideally, in most cases, depending on your system. But what you need to understand as a product manager is that tokens ideally are used for handshake between systems. It can be handshake between your front end and your back end. It can be handshake between one service to another. I'll give an example of how one service to another can work. Let's assume you are building a app like OPE, right? You have a service which is your main balance, your balance service. That's that service that allows you to transfer and uh, and fund your account. So the account service itself exists. And then you have data service, which allows you to buy data, or let's call it mobile service, allows you to buy data and then buy airtime, right? These are two different services within your system. However, when you are logging, they don't want you to log in to view your balance. And then when you want to buy data, you have to log in another login. So because of that, when you log into their accounts, they generate a, a token for you so that you can access every single service. However, to be able to access for your mobile service, to be able to access the balance service, to maybe to ask if you have balance enough to buy the data you want to buy, there has to be a service to service token, because usually in most companies, those two services are handled by different teams. So you have the service being managed in different platforms. So even though you are logged in, I need to be sure that you really, truly, truly you are the one. So this service generates a token that this service already understands how to uh, decrypt. So tokens are basically encrypted information. If I copy, I hope I can find the JWT token decryptor online. If their security allows it. Okay, decrypt. Let me see. Right? Did he just say John Doe? Is this the one I copied? Oh, okay, it's another one. Right? Can you guys see? So the token that was, when you hear tokens are basically encrypted data, ideally. Data that is encrypted that basically just tells you, that has data in them. So when it is encrypted by one service, the other service also understands how to decrypt it. So they take that JWT token, decrypt it so that they can actually be able to use the data in it. For example, this is saying OTP is actually sent, and yeah, it is not an SSO login, blah blah blah, micro front end, true, blah 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 blah, and any other things like that. I'm guessing for security purpose, they also generate other IDs. This ID then can be used by the developer to get more information about this particular token. So again, in a nutshell, um, authentications or authorizations are ideally used for communication between two services at the end of the day. Also, we have TLS. TLS, I don't oftentimes use it very much, but it's just like tokens as well. However, instead of communicating via token, we communicate through the certificates that we have. Um, when you create a website or when you get a domain, there's always a certificate that verifies that you are the one that owns the domain. So two service can actually communicate via their certificate. So this service already understands, it already knows your certificate. This other service already knows your certificate as well. And then when you communicate, you can send a copy of it so that they recognize, or something like a sample that shows that, hey, it's me that I'm calling you, blah, 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 right? There's also one way that we also ensure security, not necessarily authentication, but that will ensure security. And this is by IP whitelisting. I didn't have it in the program, so I just wanted to take some time to explain it. What does IP whitelisting means? IP whitelisting means that I give my IP for currently now. I shouldn't be doing this, but I will do it for the sake of you guys because it will change anyways. Okay, let me use my VPN. Because before somebody go and track me, we don't know where these videos will reach. All right. So what do you say? Sorry, I had to switch to VPN so that you people will not go and steal my IP. All right. So what is my IP? As you can see, this is showing my exact IP. So I can copy this IP and give it to, for example, a company and say that company A, for example, or company B, I want to, anytime I call you, confirm that this IP is the one calling you. If it is not, then it's not me, right? This is the IP of my laptop. So if I call this, if I do, if I tell you if I send a post request to you, or I tell you, give me the phone number of Adiola, one of the things I want you to verify is that the IP is exactly what I've sent to you. And what are ideally IPs? IPs are literally your device address. Your website has one, your laptop has one. If all of you go to your browser now and search my IP or what is my IP, all right, browsers save them by default, right? So you can see your IP for systems that are very complex. You can even see your IPv4, right? So browsers by default save IPs so that they can be reused. I'm using a VPN. That's why my IP is changing over time, right? You see, it has changed from the other one because of you people. All right, so every system basically has an IP. I mean, your browser saves a lot of information, including information like where you are browsing from. Currently, I'm using a Saudi Arabia IP, so it's showing that I'm from Saudi Arabia, blah blah blah, sending all those informations, blah blah blah. It even shows the ISP, right, of that particular IP. So again, companies also use IP whitelisting as a way to ensure securities of API. So what you do is you give the other party your IP, and the other party also have their IP. So when you are communicating, if there's any other IP, in fact, that's the highest level of security that anyone could ever use. Why? Because nobody, I don't know, cybersecurity people might have found a way around that, but to the best of my knowledge, nobody can what's the word now? Like, you can't use my IP as your own IP. The highest you can do is find a way to replace my IP in the third party system, or convince them that my IP is actually their IP, right? But every device, your phone, your smartwatch, every single device has an IP address, and they are basically address. Your website, www.olisholaoluyomi.com, right? That IP, that's www is actually connected to an IP address. The reason why we have google.com and many other websites like that is because we will not easily remember. If I tell you that, please, you ask me what's my website, and I tell you my website is 192.267.0.11111.2, right? You probably not remember it. But if I tell you my name is Oluyomi Olushola Michael, you remember that my name is Olushola Oluyomi. And then if I tell you that my website is olusholaoluyomi.com, it makes more sense to you. You can remember that faster than me giving you a random bunch of number. And that's why we have, again, this is not in the curriculum, but that's why we have platforms called namespace, right? These platforms allow you to buy domain name, right? This domain name basically is now connected to your IP, so that anytime you go to your website, you go to that domain, olusolaoluyomi.com, it automatically redirects to the actual IP. That means the location of that your website. So every single resource on the internet is located on a particular device. As I'm teaching you right now, my device has an IP, which means all my voice, my everything I'm doing is located on my device. So as I am showing it to you, that information, that IP address is also sent on the internet. So if any system wants to communicate to me, they can use that IP to validate that I am who I say I am. Right? So these are just basically all authentication process. I'm taking my time to explain this now, so that when we are doing practical tomorrow, you don't say I don't understand. All right. Okay, so we have webhooks, also called callbacks, right? Webhooks and callback URLs are like APIs as well, but for response, dedicated for response, right? So think of it this way, right? There are two type of ways that you can use API, also not in the documentation. So please listen very keenly. We have async and synchronous API request. We have asynchronous and synchronous API request. And what does it mean? It means that let me give you an example. A school like University of Ilorin has over 40,000 students at a time. So let's say I want to send an API request to collect all the list of students that University of Ilorin has. There's no way that that's my single request would give me all that information at once, because it would be too heavy for the internet to even handle with a single request, right? So we make it asynchronous. So which means I send the request, University of Ilorin replies back to me and say, yes, we have received your request. And then in such case, they would have already have a URL or an API that would have given to them and say, hey, when I make such requests, be sending your data to this particular URL, badge by badge, page by page. I can even give them guidelines and say, okay, I want you to only send 100 users per time. So which means it will take time to actually send 40,000. So it will be sending 100 every second, right? Because my system also has something we call rate limiting. Rate limiting is a concept or an application or a configuration that is set in a system to ensure that another system does not overcall them, right? For example, a system might over misuse it and call, because they have my API, they call me like 1 million times per seconds, right? And my system will get overheat. My system will overheat and maybe crash. So because of that, I can implement a rate limiting and say, okay, you can only call my system 20 times per second. So I give all this information to University of Ilorin, and then I call University of Ilorin and say, hey, give me all the information of the users. Again, which kind of request? What is the method that I will use to collect that kind of data? Anybody? What is the method? Is it post? Is it get? Is it which of them? You can type it in the chat. Which of them would I use? I've taught you guys today. Get, post, push, put. Anybody now? Help my life. Don't make me feel like I've not taught you now.
Can you ask the question again, please?
If I want to collect information of all the students of University of Ilorin, will I be using a post request, a pull request, a get request, a put request, a patch, or a delete?
A get
Based on
request.
Thank God, at least one person gets it. All right, so I'll send a get request to Uniphonic. Why is Uniphonic coming to my mouth? All right, University of Ilorin, and then Uniphonic or University of Ilorin, University of Ilorin, University of Ilorin, University of Ilorin. Okay, and then University of Ilorin will reply back with me with an acknowledgement for asynchronous type of request. So they reply back with me with an acknowledgement. They just say 200 okay, right? And then they start sending information to my callback URL or my webhook URL. So that's what webhook URL is for. It's for scenarios where you require asynchronous connection. I'll give another example. Let's assume you have WhatsApp API. So which means I can send WhatsApp message through API. However, because I can send WhatsApp a message through API does not mean that WhatsApp will reply back to me immediately with one API that the customer has, different action will occur. The customer will receive the message. The customer will open the message. If there's a action to perform, maybe there's a link to click. The customer will click on the link. You see, those are 3 actions that might not happen immediately. I mean, the customer might open the message today and then click the link in this thing tomorrow, right? It takes time. So which means I cannot be waiting for a response immediately. In this kind of scenario, we also use webhooks or callback URL. So we give that callback URL to the third-party system, and then that third-party system can call us and inform us of the updates of that action when it happens. Another example where it is used is for payment, right? Sometimes when payments are made, it is not resolved immediately. When you try to buy things online, right? Companies, your bank will just give an acknowledgement that yes, we have received that you have sent us, right? But we have not ascertained that this transaction is legit. Like, we have not received the money. We've seen that you have sent us the money, but we have not received it yet. So in most cases, it just tells you payment successful. But in the background, the payment provider is waiting for the acknowledgement that, hey, I have received it. I'll give another example. I don't know if you guys have seen this scenario before. You want to pay for something online, especially with Paystack, and then when you take this thing, you transfer, you say I have transferred, and then it's still loading, waiting to receive your money, right? While it is waiting because it is waiting for the third party to actually send them that acknowledgement or that status that, hey, we have received this customer's information, right? That's what webhooks are ideally for. So to recap, APIs are basically an interface that allows 2 systems to communicate together. There are 2 types of requests that you can make with an API: asynchronous request and synchronous request. Asynchronous request is request that you don't necessarily, or you can't necessarily get the response immediately, right? So you want to say, give me the information of University of Ilorin students. That's a lot of data. Apologies for that, guys. Apologies. I'm so sorry. So sorry about that. All right. Did you guys hear what I said about asynchronous and synchronous? Or you lost me totally?
We can recap.
Okay. So, like I said, APIs are basically, I'm sorry, I'm this. They are basically interfaces that allows 2 systems to communicate together. However, there are 2 types of APIs, or 2 types of requests that you can make with an API. The first one is asynchronous, and then the second one is synchronous request. Synchronous request, or sync, so to say, is that request that you need the data immediately. For example, um, uh, you want to get information about Adiola. Information about Adiola cannot be more than one page, right? I mean, what do you want to tell Adiola? Yes, the name, BVN, blah blah blah. One page is enough, right? But you want to get information about the entire Nigeria. It's a lot of data. So for that kind of request, you probably want asynchronous, because that way it can be sent to you via your webhook or callback URL. It's used interchangeably, either webhook or callback URL. Another example where you use asynchronous is when your data is not actually going to come immediately. For example, you made payments, right, for a goods and services, but the money oftentimes does not reflect immediately. So you want to use asynchronous call, right? Because usually when you make the payment, what they will reply with you is acknowledgement. Yes, we've seen that you made the payment, but we've not agreed that we have accepted it or we've received it. That end has to also be listening for, and that's why sometimes when you make transfer, it tells you it's still processing, because the the transaction is asynchronous, and the service that is supposed to receive the DLR, we call it DLR, delivery receipt. The service that is supposed to receive the data has actually not received it, right? Another scenario where asynchronous can be applicable is in case of maybe message. I sent an email to person A, and then, or maybe email is a far-fetched, right? I send a message to Adiola right now, but Adiola has not read the message. So because of that, I've not seen that yet. She has not read the message. Or she read the message, her internet is bad. I've not seen that she has read the message, right? So usually DLRs are used in this case where time differences, it could take time. Anytime you want to send a request, and this is very important for you as a product manager, because some developers don't know this, and because of that, it messes up your system. It makes your system very complex. Sometimes it makes your API, it makes your system very slow, because some requests that are supposed to be asynchronous, they make it synchronous, which means that in some cases some APIs are not meant to receive requests immediately. It's not compulsory, right? We can check the request later on. For example, a customer wants to uh wants wants to put in money in your system, right? They just want to put in money in your system. Like, you don't necessarily have to wait for the acknowledgement to receive for you to stay successful. They put in the money, they do the transfer, they say I have transferred, no problem. It is being processed, we'll get it. We see that you have processed it, but we've not gotten it yet. So sometimes that approach is actually very, very important, because it puts the user's mind at ease. They don't have to stay in that particular screen waiting for response, right? For example, imagine that when I send API requests to send you message, and you're probably in a party, right? You are probably in a party for the next 4 hours, and me, I'm just sitting there waiting for your response, right? Makes no sense, right? So in that case, that's when we use webhooks in most cases. I hope this explains it for you guys. Any questions so far? As usual, I'll stop recording. Please, guys, if you can,